Welcome everyone. In this video we will solve a physics Olympiad question from a Turkish physics Olympiad, and I will attach the original paper in Turkish to the descriptions part so that you can have a look at it. Now here's the question. We have a planet of mass capital M orbited by another celestial body little m. This is the orbit. It is circular. And the radius of that circular orbit is capital R. Okay, and we're also told by the question that the period of motion for the little m is t1. Now, this is only the first system. The second system is very similar, but a little more complicated, I would say. We still have the same mass, the same planet of capital M, and then there will be another orbit with the same radius, capital R. It is again a circle. However, this time we have three masses that is orbiting this capital M. We have three masses. And we're told that the distance between each mass is the same. So if this distance is d, this is d, and this is d. And further, we know that these distances do not change throughout the motion. So this simplifies the picture for us, all right? And the period for a mass in this system, for one of the little m's, the period is t2, t sub 2. Now we're told that t1 divided by t2 is equal to 2 over the square root of 3. And we're asked to find capital M over little m. Why don't you pause the video, try to do this on your own, and when you're ready, continue the video, please. Cool, I assume that you tried it or you just want to see the solution. Let's solve it together. Which one do you want to start with? Obviously the second one. No, obviously the first one. It is easier. At least that's what we assume. So how do we start with the first one? Well, we say that the centripetal force will be provided by the gravity. And how do I know that there is a centripetal force? Well, the mass is moving in a circle. It is in uniform circular motion, so the net force, which is gravity, should equal the centripetal force. What is the formula for the centripetal force? It is mass times v squared over r. Now, I will call this v sub 1, because in the second picture we will have another velocity and it will be called v2. This should equal, Newton told us a couple of years ago, I mean like 300 years ago, that the force of gravity is universal gravitation constant, multiplication of the masses divided by the square of the distance between them. Here we see some nice cancellations. Mass of the planet does not matter. The radius cancels, at least one of it cancels. And we have that v1 squared equals g capital M over capital R. Cool. Now we will return to the first one, but this is enough for now. So let's just consider the second one, which is a little bit more involved, but still the same idea applies. So how do we tackle this one though? Well, let's say that we focus on this mass, M. Let me draw out the triangle that is formed by these system. These are the sides are same, so this is an equilateral triangle. All sides are the same. And how will the forces be directed? Well, one will be towards the capital M, and other two masses will pull this guy towards themselves as well. What is this angle? That is an important thing for us. Well, since this is an equilateral triangle, one of the interior angles is 60 degrees, right? 60 plus 60 plus 60 gives you 180 degrees. So since this is symmetrical, one of these angles is 30 degrees. Each is 30, okay? So with this said, I will again write the first statement that the centripetal force is provided by the gravity. The centripetal force is little m v2 squared this time divided by r. The distance did not change. This is equal to, we will have the force by the capital mass, so it will be gmm over r squared plus. We will have the gravitational effect of the other two masses as well. But how do we work with them? Well, think of it like this. These two components, which are parallel to the path, let's say, they will be cancelling each other. Only these perpendicular components will be used in our calculation. They are radial, right? They are in the radial direction. They are radially inwards. That's why they contribute to the centripetal force. How do we find their magnitude though? Well, we will first need to find the magnitude of the actual force and then break it into its components using the angle. What will be the force though? It will be g m times m, so it is m squared, right? Divided by the distance between them. Now, don't write r here. Don't write r squared. Because the distance between the masses is not r. Let me show it to you. This is a triangle that we are given. And this is r, right? Well, this is 30 degrees due to symmetry. And so if I separate it like that, this side, the half of one of the sides is r cosine of theta. What is r cosine of theta? It is r square root of 3 over 2. And the other half is the same. So we have r square root of 3 as the distance between the masses. Which means we should square this. And then we square r square root. When we square r square root of 3, we get r squared times 3. So 3r squared. And we will have two of these, right? 2. But this only gives us the whole magnitudes of the forces squared. We want only the radially inward components. That's why we need to take cosine of 30 to get this component. I mean this component. Cosine of 30, what is that? It is the square root of 3 over 2. So these twos cancel. Furthermore, we see familiar cancellations. M drops, cool. R's simplify a little. Alright, now if I were to combine the denominators, I put a 3 here and a 3 here. So I see that V2 squared, let me write it with this color. So it is V2 squared equaling, let's see, 3gm plus m square root of 3 over 3 capital R. Cool. But you might be wondering, what is the purpose here? We are finding expressions for the velocities. How do we relate these to the periods which are given by the question? Well, the idea is simple actually. Perhaps you even thought of it. Since this is a uniform circular motion, we can say that the period in general, since it is in general, let me write it with red inside this bubble. Period in general is the circumference, the distance traveled, divided by the velocity, the speed that you travel it with. Makes sense, I hope. Period is the distance you travel divided by the speed that you have while you take that journey. So T1 over T2, and I want to again switch colors, excuse me. T1 over T2 is equal to, it is nothing but 2 pi r divided by V1 divided by 2 pi r divided by V2. Right? I didn't write R1 or R2 because the radiuses are the same in each case, but the velocities, they change. The speed actually, we should say speed. So this is V2 over V1. And we are told by the question that this quotient, thus this quotient is equal to 2 divided by the square root of 3. Cool. I hope so. Now, since I have expressions for the squares of the velocities, why don't we just square this part of the equation to get that V2 squared divided by V1 squared is equal to 4 over 3. Now we just substitute the expression that we found, which I can do on the new page. Well, we don't need a new page, I think. We can fit it here. Right, let me separate the workspace so that we can do it more clearly. And with a different color, of course, with this good old guy. So what is V2 squared? It is 3gm plus little m square root of 3 divided by 3r. Since we are dividing by v1 squared, we will just multiply by taking the reciprocal of v1 squared, that is r divided by gm. And oops, I realized a mistake. Look at here, we need a g, right, don't we? It was here, I didn't put it. And of course you can see that we need it because the units do not work otherwise. I should also put the g here. Excuse me for that. You should be careful. I try to be careful, but every now and then we're not careful enough. So these moments always remind us to be more careful the next time. And this is equal to then 4 over 3. These r's drop, these g's, they drop. And so we see that I will just multiply. I will multiply by 3 and... So let's see, what I'm trying to say is I will take this, hold on, I will multiply this and equalize it to this and this multiplied, okay? So what I'm basically saying is that 9m plus 3m square root of 3 equals 12m, which means, well, we put 9m to the other side, we have that 3 capital M is equal to this guy. We can divide by 3, can't we? So we do that. We have capital M. What were we asked? We were asked the ratio of capital M to little m. So it is just going to be by dividing through m, little m, the square root of 3. And this is capital M. Anyways, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.